scientists can look at that. So ice cores, like you said, and sediment cores give us evidence of ice mass, temperature, and past atmospheric CO2 concentration. So when you make ice cubes in your freezer and they have little bubbles in them, that's exactly what scientists look at. They dig 20-something miles below the Earth's surface and they pull up these ice core samples and then they analyze what's in those little itty-bitty bubbles. And that's how they're able to say, this is what was, it's now trapped, but this is what was in the atmosphere however many years back. I call it the natural history archives of the planet. And it is an indirect source of information on climate change. You can't go back and measure what the temperature was, but you can look at that proxy data. Do you have your hand up? Yeah.
How do they know how old the ice is?
I mean, I think that that's just going back through the record of, it has to do with the depth where they're searching. They look at any sort of like sediment deposits, carbon dating, that kind of thing to be able to tell what was in there and how old it is.
So, I don't know if you all know Dr. McGlue on Earth and Environmental Sciences. He's doing some really neat work with sediment cores, and I think it's in Tanzania.
Oh, really?
They're trying to look at impacts out there.
So the first scientists that did this were in Greenland in the 80s. And what they found was really interesting. They were able to detect a decade where climate changed pretty instantaneously. And it was really one of the first times that, scientists had always thought climate changes like we saw in that graph, the up and down slowly over 50,000 years. And what they saw in these ice core samples was, oh my goodness, the climate changed in this area within a 10-year span. And it changed pretty drastically. So they look at ice, and glaciers, river deltas, they look down in peat, they look in the deserts, they look all over Earth. And they dig down and they test what they find, and they're able to kind of compare these things from different areas of the planet and show, like you asked, how do they know? How are they able to test that? They look back and they compare what's found here and here and here and here, and it shows a pretty consistent temperature change and rate of change over time in all those different areas on the planet. So projections. Carmen, this class ends at 10 of, right?
Yep.
Okay. Oh, good. I guess I'm going faster than I thought, which is good. Projections for future impacts. There are projections for every area of the planet. Up until January of 2017, the EPA housed a wonderful website which had projections all over the planet. You could look up your home state, Washington, D.C. You could look up China. You could look up Kentucky, and you would find what scientists were seeing as these are the projections for your area. Unfortunately, today, that information is no longer available. I did spend 3 work days in January of 2017 saving and downloading all of the data from the EPA website. So if anybody ever needs that, I have it. I call it my secret flash drive because I feel like it's criminal or something to have. But that information was there and was available for very specific locations. This graph is really, or this image is just sort of general across the planet. We're looking at changing rain and snow patterns, changes in animal migration and life cycles, less snow and ice in certain areas, thawing permafrost, changes in plant life cycle, warming oceans, rising sea level, damaged corals, stronger storms, and higher temperatures and more heat waves, lastly, more droughts and wildfires. Now, these, I have the word projections and future impacts, but I almost need to change that to say this is really what's happening all around us. I mean, are any of these things that you've not heard about in the last 4, 5, 6 years?
Does anybody remember what it is? There's a citizen science app you can use that you record when plants start to bloom out around your area. And
I know what it is, and I can't think of the name of it, but I will. Project Budburst, right? where you, like the first flowering.
You start seeing, yeah, because it's one of those methods to try to see, how are plants responding and that.
Yep.
Is it coming earlier?
Yeah, and what we've seen by people recording this information is things are happening earlier, or, for example, in February it'll get really, really warm, things will start to bud, and then in March we get an ice storm, and it's like the cycles are off, especially in places like Kentucky.
That has a big implication for a lot of agriculture producers, is when they have, especially fruiting trees or things like that,
Yeah.
start to bloom, and then we get into the frost through, and it lose a lot of their crops.
Yep. So these next few slides are just different ways of thinking about impacts of climate change. So this is one way, thinking through our pocketbooks. Every year, NOAA comes up with this really cool map. If you just Google billion-dollar weather disasters, you will get this exact same map. Go to images, and it's really kind of interesting to look at over the last decade the different billion-dollar weather disasters that have taken place. Each one of these represents a different billion-dollar or more weather disaster or climate disaster in the United States. And when you think about this, okay, maybe my house didn't get hit by this tornado. My parents did sleep in a closet for this hurricane here. They were okay though, but they slept in a closet. They had just left Kentucky 3 days before Hurricane Harvey hit Florida, and I begged them to stay in Kentucky, and they wouldn't stay because they're stubborn old people. And they went, and then Hurricane Harvey went right up the middle of the state of Florida. They live right about here. And they slept in their closet, and I was so mad at them until they called me and it was gone. But there was some damage in their neighborhoods. A couple of years ago, there was a hurricane, or excuse me, not a hurricane, a tornado here in Kentucky. The following year, my homeowner's insurance went up, and my car insurance went up. I thought, well, I haven't been in an accident. I haven't had any homeowner's insurance claims. Like, nothing has happened in our lives, knock on pressed plastic, whatever this wood, fake wood. Nothing has happened in our lives. We have no claims. Why is this going up? So I called my insurance agent, and I asked him. And I won't name the insurance company here in Lexington, but he answered me very honestly. He said, Jennifer, he said, everyone in the state of Kentucky is paying a higher premium this year because of the tornado in, was it West Liberty? Yeah. Remember the tornado in West Liberty that hit? That tornado did so much damage in the state of Kentucky that people across the state were automatically paying higher premiums to help cover that damage. Now that may sound selfish or whatever of me to say, but the fact of the matter is we're all going to be paying one way or another, whether our house is torn down, whether we're agricultural workers and it impacts our fields. In one way, shape, or form, it's coming out of our pockets, even if it's a year later when you go to renew your insurance premiums. And Carmen, this goes along with what you were just saying. These are projected climate change impacts on crop yields. And so, as you all can probably assume, the darker the red, the lower projected yield in certain areas of the country. I keep saying I'm moving to Canada because there are many reasons to move to Canada, but frankly, they're going to make out really well up there because of climate change. Their agricultural yield is projected to go up. Why? Because it's so cold there now. However, as it warms, the growing conditions up there are going to be favorable for higher agricultural yields. Joking aside, this is a really serious thing for anybody who wants to eat. When you think about where we get our food from, where we import from, where we export to, all of the pinkish down to the red. The darkest red is a 50% decrease in ag production. Do you guys see our area of the country? What does that mean for our farmers? What does that mean for the price of the food that we pay? What does it mean for having to transport food from even further away, which then releases more greenhouse gases into the atmosphere, right? It's a whole intertwined cycle, and it's really going to hit, or it's projected to really hit our food system, our agricultural productivity pretty heavily. Hardiness zones, are you all familiar with the hardiness zone map? When you go to plant a tree or you buy flowers. You go to Lowe's, for example, and it'll tell you the zone that you should plant a certain plant in and when you should plant it. This is the 1990 hardiness zone map, and this is 2012. They've not come out with a more recent version. I'm not sure how often the USDA issues these. I look every time I do a climate change presentation for an updated one, but they don't have one yet. So it's been 6 years since they've updated this map. But when you look at 1990 and you look at the lines and how things are shifting, look at the tip of Florida, which is a zone 10. It was really just a tiny bit. Now you're about a quarter of the way up the state of Florida. So our hardiness zones, what can be grown at certain times of the year around the country is changing. It's moving further north, which is why Canada's going to make out like bandits. So in Kentucky, now this is where I told you guys I got the really specific projections for these 3 states. So in the state of Kentucky, Indiana, and Ohio, we are projected to see a temperature increase of 3 degrees Fahrenheit. Does that sound like a lot to you guys, 3 degrees Fahrenheit? You say no, you say yes. Why do you say no? And you're not on the spot. I mean, it's...
I guess if you're looking at it on a day-to-day basis, like if it's 80 degrees out, I don't think I'm going to feel much of a difference.
Okay. And you said absolutely. Why?
It's just already too hot, man.
Because 90 to 93 is terrible.
Yeah, summer's brutal. I don't want to.
Sure. Now, when you think of your body, what's the average temperature? 98.6. What happens when you have a 3-degree fever? Where are you? 98, 99, 100, 101. I told you I'm terrible with math. 101.6. So you go from normal temperature in your body to 101.6. Is that a fever in an adult? I mean, it's borderline terrible, right? You're not going to die from it, but it's pretty bad. You feel like crap, right? Now, when you think about the fact that the Earth's average surface temperature is only somewhere around 53 degrees, and you add 3 degrees onto that, would you agree that proportionally that's like an adult having a 104-degree fever?
Yes.
What happens to your body at 104 degrees? You are at the hospital. Your brain is frying. So you think about the Earth as a living system, and you add 3 degrees to it, it doesn't sound like a big deal. But it really, it's something that will impact a body in ways that if you're a human, you're going to be in the hospital. If you're the planet itself, there are going to be major impacts. Things will change. So I just want to make sure a lot of people think 3 degrees, not that much. But when you're talking about an average over time, it is a drastic change for this living system that is Earth.
So you don't think about like when we were out with Blake and we were doing the aquatic macroinvertebrates, and we warm up everything around us, what they live in is the water, right? So what happens with it? It can probably warm up, and is that important? And so what did Blake say was important? Water temperature. Dissolved oxygen, yeah. So.
And that's just in our water systems. Now you think about the critters that eat those macroinvertebrates, and the things that eat those, and the things that eat those, right? It's a drastic change for the entire system, whether it starts in the water or on land. Something's going to change, and pretty drastically. So we are projected to see an increase in winter precipitation, spring and fall precipitation. I don't know where you guys have been the last few weeks, but my backyard was flooded. It was pretty interesting. It never floods there.
And that's, and just another important point about that is, you probably don't think so much, is y'all seen these construction projects on campus? So what happens when there's a delay, and when they bid projects, they have to bid a work schedule. They will bid in work or non-work days. When they have stuff like this go up, the cost of building actually goes up too, because they have more risks that gets associated with it. And then if they miss their schedule, they probably get hit with fees. So not only is it just a pain driving around campus for a longer time because of this, but when Joe talks about prices going up, you may not think about it, but the cost of building things actually really goes up as well.
Well, and then who pays for that next year? Oh, guess what? UK's tuition's going up, right? I mean, it all comes back to each one of us as individuals in some way. Increase in summer precipitation up to 30%. More frequent extreme heat events in the summer. It's already too hot. I'm originally from Vermont. You all can have your Kentucky summer. I love Kentucky, but I love it from like October 15th through April 30th. And after that, it's too hot. I don't need any more heat in my life in this state.
If you want to do stormwater management, this is the state to be in.
Absolutely. That's a good field to get into because it's only going to get worse as far as having to engineer our way out of it. I mean, really, it's a good place to do it. Increase in frequency and severity of thunderstorms. Again, these projections that I'm telling you guys about, have we not really been experiencing them this year alone? Human health, greater incidence of heat-related illness and death. Increase in ground level ozone, which contributes to respiratory illness, especially in cities. Expanded habitat and infectivity of disease-carrying insects. Anybody know anyone that's had Lyme disease lately?
Yes.
Yeah. My mom was in the hospital last summer for 3 days. She caught a disease called ehrlichiosis, which is caused by ticks. She found a tick on her hip. A week later, she was lethargic. She stopped eating. She ended up in the emergency room. And the doctor told us if you had not brought her in today, she more than likely would have died from a tick, a little itty-bitty tick. The unfortunate part about Lyme disease is in the state of Kentucky, you will get treated for it. Most doctors will not test you for it. They don't want to have to report to the CDC. It's a lot of paperwork and it's a lot of follow-up. So when you go online and you see there's only been 12 cases of Lyme disease reported in the state of Kentucky in the last 20 years, guess what? That's a lie because I myself know 12 people alone that have had Lyme disease in the last 2-3 years. I've been treated for it twice. So it's going way underreported for multiple reasons. Do your homework on that one, it's interesting. There you go, Carmen. Water runoff from heavy rainfall. That can contribute to more waterborne diseases. Higher precipitation, more landslides, erosion, levels of pesticides, fertilizers, pollutants in our waterways, and more invasive species that our friend is now going to have to figure out how to compost. Impacts on forests and ecosystems. We're looking at a potential decline of 10 to 25%. Again, who pays for that in the state of Kentucky, right? We have a huge forestry industry in the state. Somebody's going to have to pay for that change. Types of trees that dominate the forest in our state. As you guys saw that the hardiness zone, as that changes, the types of trees that thrive here will change. Yes, sir?
The decline of forests, does that just mean natural mortality of the trees and vegetation?
It does, and I think it also has to do with like those insects like we've seen lately with the emerald ash borer. Those kinds of things are moving quickly, and so it's easier for those kinds of invasive insects to devastate. So I think it's a combination of temperature, climate, and other things that can impact our forests. Yeah. Increase in exotic species invasions, which is what I just told you. Increase in nutrient and toxic loading and sedimentation due to erosion. Higher than normal winter temperatures, which is what we were just kind of referring to, that can warm caves and disrupt bat sites. This is a projected change in forest composition in Kentucky. As you can see, a lot of our elm, ash, cottonwood, maple, beech, and birch. Within the next 40, 50 years, most of those will not survive in the state of Kentucky. We're already seeing that today. So why is this a challenge? Why is this hard? You guys now know how to define climate change. You know the difference between weather and climate. You know how we know what we know, the science behind this is how we know what was in the atmosphere 400,000 years ago. You know what the projections are. We're living the projections. It's hard to agree on, unfortunately. It is a complex system. There's a lot that goes into understanding climate. It's water, it's entomology, it's people, it's multiple things, it's human health, right? There's so much that goes into this whole problem. There's variation regionally, so what we see in our state is going to be very different than what's happening in China or than what's happening in Washington, D.C. or Vermont, where I'm from. It's hard to see the changes. I always tell people, if greenhouse gases were purple and we could look out into the atmosphere and see them, we wouldn't be where we are today. When we were younger and the ozone layer had a big gaping hole in it, we were able to see that hole in images. And people were able to get behind this idea of, we need to do something to prevent this gaping hole in the ozone layer. And we did. And we made changes, and there was legislation, and there were people that said, we've got to do something about this. You can't see greenhouse gases, and so for a lot of people it's hard to even fathom. We're not linking those projected impacts or current impacts with the issue itself. We see them as isolated incidences. The predictions are hard to say, this is what's going to happen. There are many different computer models, and they have their own limitations like anything else. And it's not just about science, it's politics, it's economics, and it's religion. It's a socially constructed issue where we hear from our leaders and we listen to our leaders, right? So if my pastor or my father or my school teacher tells me it's not happening, I'm going to listen to those people that I know and trust, right? We disagree because people see and remember information that matches what they know. It's really hard to change someone's mind. Either you think it's happening or you don't. People have partial information and then they leap to conclusions and they listen to their influential leaders, like I just explained. If my leaders don't think it's happening, it can't be happening. That is all. It is exactly 2 minutes after. Do you guys have any questions? Are we good? All right. Dr. Carmen will give you your homework. Thank you.
I will post these slides up on Canvas. You do have an assignment that Jennifer is going to prepare for you all to kind of delve a little bit more into it. I'm going to give 2 plugs. One is on Water Week on Tuesday. We do have a For the Flood. We're going to show that film, the Leonardo DiCaprio film. We'll have that there. We're going to have pizza for our food.